But while feathered dinosaurs settled one question, they raised a new one. These animals could not fly. Why were they feathered?
It was long assumed that feathers evolved for flight. But what we found was that clearly feathers predate flight and arose for some other purpose.
So why did the first feathers evolve? That's hard to tell from just the fossil evidence. But living birds may offer answers. Feathers provide insulation, so the first feathers might have helped keep dinosaurs warm. Birds also use colorful feathers in communication, in courtship, and in territorial displays. Dinosaurs may have used feathers in the same way. Feathers likely played different roles at first, and then were modified for flight. The modification of an existing structure for a new use is called co-option. It is a common way that new structures and abilities evolve. Bird wings are modified forelimbs, once used for grabbing and feeding. Just as the walking limbs of land animals are modified fins. And the turtle shell is a modified rib cage. So the co-option of feathers for flight enabled Archaeopteryx and its relatives to take to the air. And other features also evolved.
When we look at evolution after the origin of flight, we see a lot of characteristics of living birds gradually accruing.
But not in a simple linear sequence. Like other dinosaurs, this crow-sized bird had large claws on its hand. But like living birds, it had a toothless beak and a short, bony tail. While this species had teeth, its hand bones were partially fused to form a stronger wing. And this bird had a large breastbone for well-developed flight muscles like living birds. But it also had teeth.
We don't find forms that are somehow lockstep intermediate between Archaeopteryx and living birds. But we find a diversity of forms we could not have predicted.